Hello there, let's continue to learn about Kubernetes. Performing a rolling update. So what a rolling update is? Rolling updates allow deployments update to take place with zero downtime by incrementally updating pods instances with new ones. So what does it mean? Here we have a cool animation which will help to explain. Here is the service, like we have a deployment, yeah, spinning here in control plane, and we have nodes spread over three nodes, and each node has its own, each pod has its own internal IP, and the service is exposing this external IP. Now we have modified, and we have a new version. Yeah, a new pod has been created as a replacement for this one. A new IP has been assigned, and when this is up and running, the replaced pod is just killed. Here we can continue. Oh, you can see the same. A new pod has been created with new IP address. The old has been deleted. And voila, and the update happened like without zero downtime. And here we have like a nice information. If deployment is exposed publicly, let's say into like it's getting traffic, this node is becoming unavailable, then the traffic is redirected to those available one, and even this new one. So it can be that some users getting the new version, some users are getting the old version of the app. The service will load balancing traffic only available during the update. Yep, that's it. So here we have like a kubectl rollback command, which allow us to do this upgrade. So promote an application from one environment to another via container image updates. Roll back to previous version, like the same but back in case the new version contains a bug. We want to roll back to the previous stable version, and continue integration and continuous delivery of application with zero downtime. Yeah, so new features, and they are available to the end user without any downtime. So let's do some practice. Okay, get deployment. So I'm still using the previous deployment. Okay, get pods. I have two pods. Okay, describe. So in the image, I have this image, yeah, version 1. Now we will update it with version 2, and we can update it in two different ways. Here is the one of it using the set. So I'm copying it. Set image deployment Kubernetes. This is the deployment name. This is the Kubernetes. This is the new. This is the old image. This is the new one. No, this is the name of the container. Sorry. So let's do it. Get pods. We can see that new pod is creating. So new replacement has been created and both old has been deleted, or at least marked for deletion. Verify and update. So get SVC. Actually, I have already the load balancer, so I don't think I need this one. Okay, let's just, for following the tutorial, I will just create delete SVC Kubernetes bootcamp, and I have created this new service, which is not port. And it won't help in my case because I will need yeah, here we are getting as usual, we're getting the node port. I have Docker desktop, which will not work, so I have created new service. I will have to do this one. I have exposed, so curl So here you can see that is the new version of application running, the version 2. And here we have easy time. Every time you run curl command, you will hit different pod. Yes, here we have it. You can also confirm the update by running rollout status. Okay, rollout status, deployment Kubernetes bootcamp. It successfully rolled out. Okay, describe pods. Here we can see even like the events, what happened. And this is the new image version, and here the events of pulling it and creating a new container. We can roll back. So let's perform another update and let's set the tag to v10. I suppose this tag is not available, or it is. Okay, get deployments, get pods. Okay, we have an error image pool because I suppose this tag it's not valid. Yeah, notice that the output doesn't list the desired number of available pods. Run get pods subcommand. Get pods and a replica count. A replica set, sorry. Yeah, we can see that the replica set created. By the way, for after each update of the deployment, a new replica set is created. So the old replica set is deleted and the new is created. And we can see that this one has created new replica set, but because it's a error image pool, it cannot scale to the desired state. So the old replica set, which is this one, I mean relatively new one, it's still up and running. And the original one, version 1, it's here. We can see it's desired, it's not deleted, it's just 0 desired number of pods. So we can scale it up if we would like it. In case of rollback, this will revive. That's interesting. Okay, get pods, image pull back off, of course, because we don't have such image. So let's roll out. Let's undo. And it's rolled back. What's going on here now? Yeah. So we can see that we are on the version 2. Okay, describe pod. We are on version 2, yeah, because that's the most stable. And the replica sets has been not deleted, but scaled to 0. So the rollout undo command reverts the deployment to the previous known state v2 of the image. Updates are versioned and you can revert to any previously known state of a deployment. Get pods to list pods again. To check the image deployed on the running pod, use the describe pods command. Yeah, and finally we can delete it, I suppose. Yeah, and replica sets are also deleted. Great, thank you.